So now that we've talked about kind of the nuts and bolts of the helper class that's used to read in the works of Shakespeare and the lists of phrases to find, let's turn our attention to the use of splitterators in this particular program. And this part here, this discussion of splitterators, is only going to focus on the sequential splitterators. We'll come back later when we talk about parallel streams and revisit this example, and we'll look at the use of parallel splitterators. So we'll keep it pretty easy for right now. So the SearchStreamGang program, which is what we're looking at here, uses a helper class called phrase_match_splitterator. And this class is very cool because it can work for both sequential and parallel streams. In other words, we can use it both to split things in a sequential way, using a sequential stream, which is what we're focusing on now. And then later when we need to, we'll talk about how we can focus on splitting it using a parallel stream when we talk about parallel streams and parallel splitterators. So kind of like the old Saturday Night Live skit, which talked about the Shimmer non-dairy floor wax. They said it's a dessert topping and a floor wax. So this phrase match splitterator is a splitterator that's both a sequential splitterator and a parallel splitterator. So it's got elements of both capabilities built into the same general class. We're just going to focus on the sequential portions now, and then we'll talk about the parallel portions later. And the parallel stuff is really, really cool, but I don't want to get ahead of myself yet. Here's the way we actually use this in our program. So there's this search for phrase method. We've talked about this before a couple times. You can find this in the SearchStreamGang class. And the key here, the part that matters, is the part that's going to make a stream of matches where the phrase we're searching for is found in the input string we're searching. So given a phrase and an input string, the phrase match splitterator is passed the input string and the phrase, and then that splitterator is passed to stream support.stream, which is a factor method, which will go ahead and create the appropriate stream that's going to be defined by applying the splitterator, looking for the phrases in that input string. Right now, we're going to focus on the sequential version, so let's just pretend, for the sake of discussion, that the parallel parameter here is set to false. So it's not a parallel stream, it's a sequential stream. What we end up getting back, of course, is a stream of these result objects that indicate where the matches occurred by the indices into the string, and then we're going to collect that into a list. And that's what's going to be stored in our search results object, which we've talked about before. This is the way it gets used in the context of the broader program. You can see here that we take the stream, which is the stream of phrases that we're looking for, and then we map that using search for phrase, and that, of course, converts the stream of strings into a stream of search results. So that's specifically where this thing takes place, and search for phrase is the part that manages the splitterator to do this. Here's just a simple example of what this looks like. So let's say we're searching in the play text for Hamlet, and we're looking for the phrase brevity is the soul of wit, which of course occurs in Hamlet. And what we'll get back from this will be a result object that indicates that that phrase appears at index location 54,739. So brevity is the soul of wit begins at the character offset into the play Hamlet, 54,739, which might be helpful if you're trying to do a search to figure out where these phrases come from. The way this actually works in terms of the implementation is we have this class called phrase match splitterator, which uses this Java regular expression package to create a stream of search results, result objects that will keep track of the number of times a phrase appears in a given input string. And you can find all the code here at the file at the bottom of the slide. So phrase match splitterator implements the splitterator interface, which is we talked about earlier, is essentially the way in which you can customize the splitting phase and the iterating phase of a Java data source. In this case, it would be the elements that we're looking for. And so Spliterator is an interface that defines 8 methods, most important of which for our purposes are try advance, which we focus on here, and try split, which we'll focus on when we talk about parallel streams. There's a bunch of different fields that we define that are used to implement the Spliterator. And some of these fields, once they're set, they never get changed. Some other fields get updated later by the try split method, which we will not look at the moment. So that's why they're not defined as final. It's usually a good rule of thumb to try to define as many of the fields in a class as final as you can get away with, because it simplifies certain things like Immutability becomes easy if everything's final, and synchronization becomes easy. But in this case, we couldn't quite get away with that. Here are the different fields that we have. One field is the input to the character sequence that contains a single work of Shakespeare, like Hamlet or Macbeth. We then have the string, that's the phrase we're searching for, like brevity is the soul of wit. We have this pattern, which is the regular expression in Java, that is the representation of the phrase as regular expression. We have something called a matcher, which is an association between a regular expression and the input that we're going to be searching. So it's basically a pattern matcher. And then we have a couple of other fields that are used by the parallel spliterator, one of which is called min split size, which is used by the parallel spliterator to decide when the input has gotten small enough that it's not worth trying to split the input anymore. And so you just go ahead and process it sequentially at that point. And then the final field here is called moffset. This is also used by the parallel streams spliterator, and it's used to keep track of the index location in the original string. That won't make much sense now, but when we come back and talk about parallel streams, you'll see exactly why we need to do this. So that's an overview of the class purpose and the methods and the fields. Now, in the next video, we're going to talk about the implementations, or the implementation of the constructor and the try advanced method.